Hello and welcome to another exciting session on learning statistics. Today we will focus on continuous probability distributions, including uniform and normal probability distributions, how to apply them, and the importance of Z value for solving real world problems with the standard normal distribution. So let's dive into this. The learning objectives in this session include learning about how the uniform distribution works and how to apply it to determine probabilities. Then to understand the normal probability distributions properties and how it is shaped. Finally, to explore how to use the standard normal distribution and apply it to the real world problems using the Z value. Okay, so let's go through this. So these are the objectives we were talking about. Now, what is a continuous normal distribution? Continuous probability distribution. In another session, we talked about this briefly, where we, compared, where we defined discrete probability distribution and continuous probability distribution. So basically, discrete probability distribution includes counting of numbers, where we can count the numbers. Numbers are not too many and we can count them easily. So when we are able to do that in any distribution, we call it a discrete probability distribution. In continuous type of probability distribution, we have a very large number of values within a range. So it is practically impossible to count all those. Basically, what we do is we measure. So we, instead of counting, we measure the the area under the probability curve, right? So that's called continuous probability distribution. A range that's min to max includes infinite number of values, right? And we can only measure them, not count them, right? There are some properties related to that area under the curve is always one. So that means that area under the curve represents the total probability. And what is the total probability? What is the maximum probability that we can have? That's 100%. So 100 divided by 100 is 1. So that's why the area under the probability curve is always 1. Okay. And secondly, for any specific value, the probability is 0. What does it mean? It's meaning that probabilities are calculated over a range of values. So probability is not calculated per element of the shaded area. Okay, and it's not possible. So only we can measure it from point 1 to point 2 or point A to point B. Okay, individual elements within the shaded area or under the curve, it's not possible to measure the probability of that because it's so tiny and so many of them. That's why if we look at any specific value under the curve, probability curve, the probability is zero for that. Okay. Okay, so now let's look at uniform distribution. All these are forms of continuous probability distribution. Why we use uniform distribution? Uniform distribution is used when there is no information favoring one outcome over another. All outcomes are equally likely. This makes it a distribution of no bias, requiring only the minimum and maximum values, because we only use the range, right? So basically in a uniform distribution, we have minimum value and a maximum value. So the probability is uniformly distributed between these 2 points, and probability outside of that range is 0. We can also find mean and standard deviation for this probability distribution. So mean, let's look at our mean and standard deviation for that is. So if you look at this is a shape of a uniform distribution. So you have a minimum point A and a maximum B. So so what we have is we have the mean is a midpoint, which is A plus B divided by 2, like A plus B divided by 2. That is a midpoint of the interval. And what is the standard deviation? Standard deviation is it measures the dispersion of the distribution with respect to mean. Okay, so standard deviation, right? So so probability basically is the probability is given by the relationship 1 divided by B minus A. Okay, and area, the area under the curve, what it is? Area under the curve is like this is a rectangle kind of shape. So length multiplied by width, or you can say base multiplied by height. So a base is what? B minus A. And we know that this value is this side, the height of this rectangle is 1 divided by B minus A. So area under this curve is equal to 1 because it's total probability. The total probability, 100% probability is under the curve. Okay. And it's 1 because it's 100%. So outside of this shaded area, the probability is 0. The probability within this, this range, the total that is shaded is equal to 1 or 100%. So the mean is, as I said, mean is A plus B divided by 2, midpoint of the interval. And standard deviation is given by this formula, B plus A squared divided by 12, the whole square root. That's the formula for that. We can look at some example here, one example here. So example is a Southwest Arizona State University provides bus service to students while they are on campus. Students arrive at the bus stop at random times. The time that a student waits is uniformly distributed from 0 to 30 minutes, right? So minimum is 0 and maximum is 30. That's given to us. So first we have to draw the graph of the distribution and then show that the probability of any value between 0 and 30 is equal to 1. That's 100%. And then we need to look at we have to find the mean of the distribution and also standard deviation of the distribution. And we know the formulas already, we saw. And what is the probability that a student will wait more than 25 minutes? Then we have to find that. So let's take a look at this. All right, so we know from the given values that the range is 0 to 30. 0 to 30, so 0 is the minimum and maximum is 30, right? And we know that this value, right? This value, remember we had if you see this formula relationship here, we had 1 divided by b minus a, the height, right? Height of the rectangle. And if we, that means 1 divided by 30 minus 0, and that is equal to 0.0333. So area under this curve, that's what we are interested in. This is the shape of the graph based on what is given to us. So what is the total probability? Total probability. What is total probability? Total probability is base of the rectangle times height of the rectangle. The height is 0.0333 multiplied by 30 minus 0, right? And it comes out to be 1, right? So 1 divided by 30 minus 0 multiplied by 30 minus 0, it cancels out, is equal to 1. That's 100%. Now, mean, we can find a mean. Mean is a plus b by 2. So 0 plus 30 divided by 2 is 15 minutes. That's the mean. And the formula for standard deviation is b minus a squared divided by 12 whole square root. And we can find that value by substituting the numbers given to us is 8.66 minutes. So far, so good. Okay. Now, the last question in the example was, what is the probability a student will wait more than 25 minutes? More than 25 minutes is like the minimum 25 minutes. So minimum changes from 0 to 25 here. And we know that maximum is 30. That means the student has to wait from 25 to 30 minutes. So the area that we have here is, the range is now max minus minimum. 30 minus 25 is 5. So b minus a is 5 here. And but original height, like is b minus a. So what we have here is height. Height is what? Height is 1 divided by 30 minus 5. 30 minus 5. And that gives us 0.0333. So when we multiply this, okay, so multiply this, we get what? 0.1667. That is the probability of a student who will wait more than 25 minutes. So normal distribution. Now let's look at a normal distribution. Normal distribution looks like a bell-shaped curve where you have mean and the dispersion is uniform on both sides of the mean, and it's symmetrical, right? It's bell-shaped because you have in the center is the peak, center is mean, and if it's a 1 on the right hand side, then -1 on the other side. If it's 2 on the other right hand side, then -2 on the left hand side. It's a mirror image. It's like a symmetric. It is also asymptotic because the way we define asymptotic curve is that that decreases from a point where it's just, in the midpoint, it decreases, but it never touches the base. Just goes continues indefinitely to infinity, whether it's the left hand side of the mean or right hand side of the mean, never touches the x-axis. Okay, and the way to describe a normal distribution is using a mean and standard deviation. Okay, so let's take a look at it, how we find mean and standard deviation for normal probability distribution. This is how a normal probability distribution looks like. And as you see that when you put the bell upside down, it looks like a bell-shaped curve. Okay, it has two halves. They are symmetrical, right and left. They look similar, symmetrical, and you see the edge that goes toward x-axis is called tail in both sides, the positive tail or negative tail. And negative, it goes all the way to minus infinity. The right hand side goes to plus infinity, and the midpoint is a mean, right? And the point to note here is that for a normal distribution, mean, median, and mode are all equal because it's totally symmetrical. Okay, right hand side is a mirror image of left hand side. So these are some shapes that how normal distribution could look like. Various it could take. I mean, essentially the shape of doesn't matter. Actually, it's like how much height it is or how spread it is, but the shape would look like a bell-shaped curve. So you see in this here, you have three different curves here. They all shaped like a bell. Similarly, you see that those, these right hand side, similarly, you have blue, you have green, and you have red. They all look like bell-shaped curve. Although their values are different, but they all look like bell shape. They all look like bell shape. So now standard normal distribution, probability distribution. This is a form of a normal distribution where mean is 0 and standard deviation is 1, always 1. So mean is 0 and standard deviation is 1. Okay, and in this case, we use z values to calculate the probability distribution. So what is z value? Z value is the signed distance between a selected value designated by is x. Basically, you have a point x, then there is a mean mu, and z value specifies the signed distance between x and mu, and then divided by standard deviation sigma. So we can convert any normal distribution to standard normal distribution by using this formula. Z is equal to x minus mu divided by sigma. Okay. So using the Z value, we can find the area. Area means probability under the curve. Area under the curve means probability. So if we know the Z values, we can find the area under the curve or probability for various ranges. And we will look at some examples. Now, I mean, you can see this table here. You have area under any normal distribution. So we have various values of 0 and Z. So area between 0 and the value of Z. There are you grab any book on statistics, on the back side, there are a whole bunch of tables. They have these values that you can just simply look up and use them. So this one this example shows that Z value of Z is 1.1. Then you add that to 0.02. So it's 1.12. 1.12, because the way you read it, this table is that you look at, let's say you are interested in Z value of 1.12. So you first look at this first column here. So you have 1.1. Now you need to add a second after digit after the decimal, and you can find by going this way, and use 0.02, and you add that to 1.1, that gives you value for 1.12. And you look at this, draw a line here, draw a line, a vertical line here where they meet. So basically the area under the curve for the Z value of 1.12 is 0.3686. That's the probability. Okay. All right, so standard normal probability distribution. So this is example here. Ride-share services are available internationally. A customer uses a smartphone app to request a ride. Suppose the weekly income of ride-share drivers follows a normal probability distribution with a mean of 1,000 earning and a standard deviation of $100. Right? So what is the Z value of the income for a driver who earns 1,100 per week? So now what is given to us? We have a mu. Mu is a mean, which is 1,000, and this is standard deviation, sigma, 100. And the value that we have to find is a variable is x. X is 1,100 per week. So we have the values we need to find the Z value, and Z is x minus mu divided by sigma. So 1,100 minus 1,000 divided by 100 gives us 1. So now we can use the Z value table to find the probability. Okay, let's take a look at it. So this is the table, and we know the value of Z is 1. And 1. So we have 1.0 here. This nothing of no other digit after the decimal. So we only have like this 0.00 plus 1.1. So 1.0 is 1. So this is the value 0.3413 that we got. This is the probability that we need to. This is the answer to the problem, right? So between 0 and 1, right, the value of Z is 1. So we are measuring the value of Z across x-axis. So Z0 is a mean is always a 0 in a standard normal distribution. And now we can't see the value of Z here is 1 for us, but the way we found it. And table gave us the area 0.3413. This is the shaded area for that. Now, What's the probability a randomly selected driver earns less than $1,100 per week? Okay, so 1,100, and so we know that the sigma is given to 100, right? Sigma is what is 100. So mean is 1,000, and you add one sigma, which is 1,100 here. So everything on the left hand side, because he's saying find a probability a randomly selected driver earns less than 1,100 per week. So everything less than 1,100. So if you look at this curve, so all the shaded area on the left hand side, okay. And we already know that for between 1,000 and 1,100, the probability we found before was 0.3413. And what about the probability for the remaining area here? Well, it's easy, because the total probability is 1 and half is 0.5, right? So half of this half of the area under the curve is 0.5. The total is 1. So we have 0.5 here for the remaining, and then we already know that between 1,000 and 1,100 we have 0.3413, and we can add these up. That becomes the probability that a randomly selected driver earns less than 1,100 per week. Okay. Okay, so standard normal probability distribution. Now, another example here. What is the probability a randomly selected driver earns between $790 and $1,000? Okay, so we have two values, min and max. We can use not min and max. Basically, yeah, you can say min and max, because 1,000 is given to us as a mean, right? And so we have to see the difference between two. So Z, the formula is x minus mu divided by sigma. So 790 minus 1,000 divided by 100, and it gives us this is not right actually. It should be minus 2.10, not minus this dot here is like at the wrong place. It should be after 2. So minus 2.10, right? So now we got the value of Z, and now we need to find the area. We can use Z table. So area from minus 2.10 to 0 is same as, because it's symmetrical, it's a normal distribution, so we can ignore the sign. So basically what we have is 2.1, and there's no other decimal point here, so we can stay in the first column here of the table here. So 2.1, and we got 0.4821, and that's our answer, right? So this is our answer. So basically, minus 2.100, this is 0, and this is the value of Z, which is negative. So based on what we calculated here is the probability that a driver earns between $790 and 1,000 is 0.4821, or if you multiply this by 100, it's like a 48.21%, right? All right, so another example of a standard normal probability distribution. What is the probability a randomly selected driver earns between 845 and 1,200 per week? Now, you can see that it's not 1,000. 1,000 we know that it's a mean value. Now this is not a mean value, it's 1,200 per week. Okay. So we have basically we have two values with respect to the mean value 1,000. All right. So we can find we have a Z1 or Z1 value 845 minus mean divided by sigma minus 1.55, and the second value of Z is for other extreme 1,200 minus 1,000 divided by 100 is 2. So as you can see this table here, we have 1.55. So 1.5, and then we need another 0.05 here. So we go this way and we find 0.05. Okay, so which value we pick here? We go down and go from this side, and this is the value we're interested in, 0.4394. Okay, so now for two is like that. We don't have any other decimal point, so we can just stay in the first column. And for two, the value we are interested in is 0.4772, right? All right, so we got the values for both. We got the probability for the first value of z, and we got the probability for second value of z. So now we can plot it. All right, we can plot it. On the negative side, we have 0.4394. On the right-hand side, we already see 0.4394, which was related to 1.5, like this one, 0.4394, right? And 0.4772 for 2, value of 2, positive. So this is the shaded area. This is the probability we add. I mean, this is on the right-hand side of the mean, and this is left-hand side of the mean. Okay. All right. So another example here. What's the probability a randomly selected driver earns between $1,150 and $1,215 per week? So we can use the same formula, and we find first value of a z as 1.5, second as 2.15. Here, we can look at for 1.5 here, like this one here, and they're both positive. Like before we have one negative, now we have both positive. So 1.5, and there's no second decimal here, so we don't have to go this way. So we stay in the first column, and the value we find is 4.4332. And for the second one, we have 2.15. So we look at this value first here, 2.1, and we also need a 0.05 to make it 2.15. So we go this way and go to 0.05. And this is the column we are interested in. So we go down, and from here 2.1, we go this way. So the value we found is 0.4842. So we got two values, 0.4842 for second value of a z, and for first one we got 4.4332. That's all we need, right? And we can plot this. Because both are positive. And we plot it, we get this kind of shape, right? We get this kind of shape because it is between 1.5 and 2.15. So what we have to do is we have to get these values, and like everything, this means 2.15 mean what is 2.15? 2.15 is with respect to mean, right? 2.15 gives us 0.4842, right? So that is everything. That's everything from this dotted line all the way to mean total right here. This one. Okay. Now for 1.5 we have 0.4332, which is this dotted line, and all the way to up to this midpoint here. So what we need to do is we need to subtract the area for this Z2 from the area for 1.5 to find the shaded area. When we do that, and the shaded area we got is, the value is 0.0510, right? All right, so now let's look at percentiles. Example is, what is this 97.5 percentile of the weekly earnings? Well, the answer is 0.4750, but how we found it? Let's take a look. as I said, there are many standard tables available in any statistics book, or you can even go online and find those tables. I found this on online, and this is a source for that. And this is a Z-score or Z-score table for percentiles. And we know that, let's see, and we know that we are looking at a 97.5 percentile, right? So if you look at this table here, we have percentile 97 here, this one, and 98 here. So 97.5 is a midpoint of these two. So basically, these are the values corresponding to these, the Z values. What we can do is we can add them up and divide by 2, get the middle point of these. And the value, it comes out to be 1.96. So the Z value corresponding to percentile 97.5 is 1.96. So once we have the Z value, it becomes easy for us to find the area. So what we can do is we can go use this table again, Z table, and simply find the value that matches with our Z value. So what we have here is 1.9, right? 1.9 here. And we also need to 0.06 because it's 1.96. So we go this way, all the way, we got 0.06, right? This makes it 1.96. So we go down here, I go horizontally right here, and this where they meet, rows and column, and we get this value, 0.4750. This is a standard Z table. So that's how we found it, this shaded area value here, 0.4750. Okay. And if we can also find value of X corresponding to this. Okay, which one we can say, hey, which driver or which value corresponds to this 97.5 percentile. And we can simply use this formula, X is equal to mu plus Z sigma. If this is a same formula we have been using to find the value of Z, it's like a rearranged, right? So we can substitute some mu is 1000, and we know that standard deviation is 1.96. So sorry, 100, and Z value is 1.96, and gives us a value of 1196. Okay. So basically, this refers to the earning, not a driver. So the earning that makes 97.5 percentile, that earning is $1,196. Okay. Now, finally, we can also use empirical rule. And empirical rule applies to both normal distribution and standard normal distribution. As you know that standard normal distribution is we have mean is 0 and standard deviation is 1, always 0 and 1. However, in a normal distribution, non-standard, we have the values, different values other than standard deviation can be any value. So this one here say practically all. This refers to the same shape, same curve, everything. We have with sigma as a standard deviation, and mu is a mean in case of normal distribution. And so because it's a symmetrical, both sides, it's a 1 sigma, mu plus 1 sigma on this side, mu minus 1 sigma on the other side, mu plus 2 sigma on the right hand side. So we have equally dispersed mu minus 2 sigma on the left hand side, and so on. And this shape you see, this is a normal distribution curve. But when we convert that normal distribution to standard normal distribution, we have only zeros and ones. So basically, one standard deviation is 0 to 1, and 2 standard deviations are like a 0, two standard deviations here, one equal. So 1, 1, 1. So it's one here. This refers to this 1 sigma. This is 2 sigma. It's 3 sigma, and same is on left hand side because it's symmetric. Okay. And in normal distribution, we use the scale of X on x-axis, and in standard normal distribution, we use scale of Z along x-axis. Okay, I hope this was easy to understand for you guys. All right, so this concludes our session on continuous probability distribution. We talked about various applications of that, and these are applicable in day-to-day life a lot. We will discuss more in coming sessions. I hope you enjoyed this. Thank you for your time, and continue to look for more sessions like this. Stay tuned, stay connected. More to come. Thank you very much. I'll talk to you later. Thank you. Bye.